Welcome back to section 8.2, page 2. One thing I messed up with in the last problem I wanted to show you is it shouldn't be square units. We were given these were centimeters, so go ahead and cross that out and make them centimeters. Okay, now back to page 2. Okay, so we've got a theorem for the area of a trapezoid. So it says the area of a trapezoid whose bases have lengths b sub 1 and b sub 2. So b sub 1 is just the first base. Okay, so we'll call that one the top one. And b sub 2 is the second base, the bottom one, but you could label them either way. And altitude h, so here's our altitude of h. And we should label that with an h. Okay, so then what do we know from there? We have a formula that says area equals 1/2 h times base sub 1 plus base sub 2. What may make a little more sense is if we rewrite this as h and then times b sub 1 plus b sub 2 over 2. Okay, so what we're doing is we're averaging, we're adding them up and dividing by 2. We're averaging the bases and then multiplying by the height. So then it's sort of like a base times height thing. You're just taking the average base. Okay, I wanted to show you why this is true. So I went ahead and highlighted the two triangles that we're going to talk about. So if we figure the area of this triangle and then add the area of that triangle, that should equal the whole thing. So we're going to say area of triangle, and we're going to call it ADC. And then we're going to add to that the area of triangle ABC. Okay, and see if we can come up with a formula. So here, this first triangle ADC, the base, first of all, what's the formula? 1/2 base times height. Let's put that in for each case. All right, then 1/2. What's the base? In this case, with this triangle, it's b sub 2. What's the height? It's called h. Okay, second triangle. Now, I think it might be handy to flip it around and look at it this way. So here's our triangle. This is our base, b sub 1. What's our height? Well, we have to extend it because it's an obtuse angle. We need to do this with it and drop it down like that. Okay, so now do you see that it's the same height as this? We're connecting these two parallel lines as a trapezoid. These lines are parallel, so they're equal distant everywhere. So that's also h. All right, so we had a different base. We had b sub 1, but the height was the same. Okay, now what I want you to notice is that there's something in common here. There's a 1/2 in both, so let's factor it out. Hopefully you remember that. And there's an h in common, so let's factor that out. Well, when we factor that out, the 1/2 and the h, what's left in this one? First one, b sub 2. What's left in the second one? B sub 1. And isn't that our formula? Area equals 1/2 h. We've got it reversed, but it doesn't matter. Add the two bases. That's the formula we're going to use. So let's try it in this next problem. Given that we have a hexagon, okay, so what that means 6-sided, so R, S, T, V, W, X, R, okay, with these, let's see, WV is parallel to XT is parallel to RS. Okay, so all these lines are parallel. And then we know that RS is equal to 10. So let's go ahead and label that as 10. And we know ST is 8, so let's label that as 8. TV is 5, that's this piece here. Okay. WV is 16, that's the whole piece. Okay, the whole piece is 16. WX is congruent to VT. Oh, so these two sides are congruent. Well, that tells us that that's 5. It also tells us we have an isosceles trapezoid, don't we? Okay, we're supposed to find the area of the figure. All right, so to find the area, I think we want to break it up into the area of two different things. We want to say the area of the rectangle plus the area of the trapezoid. So we're going to say total area equals the area of the rectangle plus the area of the trapezoid. Okay, so the area of a rectangle, the formula is base times height. The area of the trapezoid is equal to 1/2 h b sub 1 plus b sub 2. Or the other version of the formula, whichever you like best. Okay, so let's try to plug in here. B times h. Well, we know that for the rectangle, it's going to be 10 times 8. That's easy enough. 10 times 8. 1/2. Okay, now we get to the trapezoid. We do not have the height, so we're going to have to work on that. Do we have the bases? We do have the bases. We know that the base here is 10. How do we know that for sure? Well, we know we have a rectangle because we know these two lines are parallel, okay? And because they're parallel, that means that these two angles have to be supplementary. So that means that this would be a right angle and this would be a right angle. So we know that the opposite sides have to be the same. So I'm going to leave a space for h like this. And then b sub 1, I'm going to put in 10. And b sub 2, I'm going to put in 16. Okay, so we just need to find this h. This is what we're looking for right here. Okay, so if I go ahead and make that like that, and let me keep going here. Let me do it here too. So we can always do that. We can, make another a line, draw a line perpendicular. So then what do we have? What do we have right here? This has to be a rectangle because these two are right angles and these two are right angles. So if we have a rectangle here, what do we know this little dimension to be? We know that to be 10 because opposite sides of a rectangle are congruent. Okay, so we're trying to figure out this one right here, aren't we? Well, how are we going to find that out? Right here we have a triangle. So in this triangle, if we could get one of these, well, this side, then we could find out that one. So can we figure out this side? We can, because we know that this is 10 and the whole thing is 16. So this is going to have to be 3, isn't it? Because these triangles are congruent. That's easy enough to see. We know that their heights have to be the same because it's a rectangle. This shape is a rectangle, these heights, and these are parallel lines, so they're equal distant everywhere. So that's congruent. These pieces are congruent. We're in a right triangle, so by HL, these two have to be congruent, which means this is congruent here. So they're both 3s. Okay, so now all it's a matter of doing is Pythagorean theorem on this triangle. So use Pythagorean theorem to find height of the trapezoid. Okay, so we have a squared plus b squared equals c squared, and we know the hypotenuse is 5, so we're going to put 3 in for a, we don't know b, and 5 in, so we get 9 plus b squared equals 25. We go ahead and subtract 9, so that gives us b squared is equal to 16. We take the square root, plus and minus. We get b is equal to 4. And we don't want the negative because we know it's a height. So now we know that this is 4. That's what we needed there. Okay, so we're going to plug that right in here. Okay, so then we can say, what do we have? 80 plus 1/2 times 4 times 10 plus 16 is 26. Okay, so I'm going to do these two first. 1/2 times 4 is 2. And then times 26 is going to get us 52. And when we add that together, we get 132. Does it tell us what kind of units we have? It doesn't. We're just going to say square units. And that's our total area. Okay. All right, we've got another theorem here. It says the area of a quadrilateral with perpendicular diagonals. Okay, so the area of any quadrilateral with perpendicular diagonals of length d1, d sub 1, and d sub 2 is the area 1/2 times the two diagonals. So here they've asked us to do a problem. We've got a square. Okay, and in this square, they tell us the length of each side is 4. Okay, 4 inches. Okay, and we're supposed to use this formula, which means we're going to have to figure out what the length of the diagonal is. Okay, so when we look at this, we know here we have a right angle here. Okay, how can we figure this out? Well, we can use the Pythagorean theorem to figure it out. So let's go ahead and say use Pythagorean theorem. So we have a squared plus b squared equals c squared. We don't know the side across from the right angle, so we're going to put a 4 in for these others. So we get 16 plus 16 equals c squared, or 32 equals c squared. Take, oops, I need the square root of both sides. And we're just going to say the square root of 32, positive. Okay, that's the length of the diagonal. Now, do you remember that in a square that the diagonals are congruent to each other? Okay, so we know that d sub 1 then is equal to the square root of 32, and d sub 2 is equal to the square root of 32, since diagonals are congruent in a square. All right, so to figure out the formula, area equals 1/2 d sub 1 d sub 2. We plug in here, we get 1/2 square root of 32 times the square root of 32. And that's going to be 1/2. When you multiply those, I don't know if it helps to do it this way. Some of you may just know that that's 32, but if you multiply 32 times 32, you get 1024. And then if you take the square root of that, you're going to get 32. So the final answer is the area is going to equal 16. So let me just show you a second. Square root of 1024 is equal to 32. Okay, we had units, so square inches is our answer there. Okay, one last theorem, or corollary, area of a rhombus. Well, a rhombus is generally, it's a quadrilateral with perpendicular diagonals, isn't it? So it's going to satisfy this formula. So, here's your diagonal here, here's your diagonal here, okay, and you're just going to multiply those, d sub 1, d sub 2. Okay, that concludes page 2.